So let's see that we can have to solve the actually linear inequality equations. So let's say we have, so if we say linear inequality equations, these are the linear equations. Instead of having equal sign, we have the inequality symbols, like less than, greater than, less than or equal to, or greater than or equal to. Those are the actually inequality symbols you have to incorporate with. Let's say you have 2x and let's say minus 7 less than, let's say, 11. So what is the solution of this problem? So you have to treat actually inequality symbol the way we treat equal sign. So now in this case we'll have to transfer negative 7 to the other side. So we'll have 2x less than 11 plus 7. So we'll have 2x less than, now have it as 18. We'll have to divide both sides by 2, where we'll have x less than should be 9. So this is the solution. In our interval notation, we'll have it as now x, so should be, we'll have it as now negative infinity, comma 9, like that. Now on the number line, we'll have it in this case the way we discussed it before. This is now unbounded interval, that is negative infinity, and let's say this is 9, we'll have it as this. So that is the number line you should have to understand. And in that case, let's say we have this case, let's say have a 3x, let's say over 5. So the same principles we did about the solving, let's say the fraction, actually about the algebraic fractions, also be the same way here. To be the same principle, solving the algebraic fractions also be the same way here. So less than, let's say, 1. So how should you be able to have this one out? So we may think of expressing this one as the single as a single fraction, or else you should have to do this one. Let's think of multiplying everything by 5 to eliminate this actually a denominator. So have it as 3x minus now a 5 times x minus 1 over 3, the rest than, that should be 5. Then we have 3x minus 5x, and that should be, let me have this case, so should be 3x now minus 5x, and that should be plus 5 over 3, so less than, that should be a 5. Then also do the same with 3. We'll have to multiply everything by 3, of which you have it as 9x minus 5x minus 5 less than, should be 15. Now we'll have it as 9x, so 9x minus 5x is given as 4x, so that will be given as 4x less than a 15 plus 5, so have it as a 4x less than 20. We'll have x being less than, should be now 5, so have negative infinity, comma 5, like that. On the number, you can also have it in that case. So take note of that. And let's say we have this case. Let's say we have negative 1 and less than or equal to, let's say, 1 minus 4x divided by, let's say, 3, and that should be less than x. This should be less than or equal to 1 over x, so should be less than or equal to 1. So what is that one? So now this one, we are having two actually inequality symbols. Other than the answer should also have the two inequality symbols, and the answer has to be in this order. The solution has to be in this order. We should have a less than or equal to x less than or equal to b, where a and b, these are the real values. So that should be the solution. At the end of the day, we should have x on the middle there. So let's think of multiplying everything by 3. of which you have it as negative 3 less than or equal to 1 minus 4x less than or equal to 3. So that is the way to go. And then you have to transfer 1 to either side, to both sides. So this one has to be transferred this side as well as this side. And of which you have it as negative 3 minus 1 less than or equal to should be 4x, and the less than should be 3 minus 1. Now of which you have it as negative 4 less than 4x, and the less than or equal to also should be 2. So we have negative 4 here. Then now we have to divide everything by negative 4. Now mind you, as we are dividing everything by negative 4, the inequality symbols also has to change to be likewise, or they to be opposite. So now we have negative 4 over negative 4 greater than or equal to negative 4x over negative 4 greater than or equal to, and that should be 2 divided by negative 4. We should have that one as that. So now which means we can have it in this case. We'll have a 1 greater than or equal to x greater than or equal to should be 1 over negative 2. So take note of that. And of which, as it stands here, this is the same as having negative half should be negative half less than or equal to x less than or equal to 1. That is the same as that. So take note of that. Now let's say if I have this case. So by the way, which means this is a bounded interval where that is the same as negative half and a comma should be. All these values are part of the intervals. If the number line will also be in the same way we discussed it before. So bear that in mind. And say we have this case. What if we have a case like this, where now we have 1 minus, let's say 2, and let's say x plus 3, that we have minus x less than or equal to, let's say 1 minus 2x. So what is the solution of this problem? So let's think of simplifying it first where it is necessary. So have to expand this one. That will be given as 1 minus 2x and a minus x less than or equal to 1 minus 2x. And of which you have this x, and also this x. Now having the like terms, we'll have it as negative 2x, negative x, and a plus 2x less than or equal to 1 and minus 1 plus 6. Mind you, as we are transferring the negative actually number, the sign shouldn't have to change. But when we are dividing both sides by negative, that's when the sign has to change. But as we are transferring, we want to change the actually inequality symbol. So have this is negative 3x and that plus 2x. That will be given as the negative x less than or equal to, now have it as a positive 6. So have divide both sides by negative 1. In that case, it means the inequality symbol has to change. You have it as x greater than or equal to negative 6. So that is the solution, of which we can have it as now negative 6 should be a comma positive infinity. So that is on the number line. You can also have it on the number line, and the way we discussed it before. So take note of that. And what if we have this case? Let's say have 9, let's say over 10 raised than, let's say a 2x minus 1 over should be negative 4 raised than, that should be 90 over should be 100. So what is the solution of this one? So let's think of multiplying everything by 10 first. So have it as 9 less than, so should be 9 less than, now have 20x and then minus 10 over negative 4, and less than, we'll have it as 900 now over 10. Now of which that is the same as having, should be over 100. So that is the same as having these two guys out. So these zeros out. So now have it as a 9 less than 20x minus 10 divided by negative 4 less than now 9. So also have to do the same with a negative 4. So have negative 36. And the symbol has to change. You have it as 20x minus 10 should be that, minus also should be negative 36. So what would be that one? So now we can have it as this case. So now have it as negative 36, and that should be plus 10 greater than, should be 20x greater than negative 36. That should be plus 10. We have to transfer this negative 10 to both sides. So that would be given as negative 26 greater than 20x greater than, should be negative 26 as well. So dividing both sides by 20, we'll have it as negative 26 over 20 greater than, should be x greater than negative 26 over 20. And of which this is the solution. So take note of that. Now what if we have this case? Now we have, in this case, that should be, of course the solution seems to be a very should be complicated, but that is the way to go anyways. You should just have to be in your track, and should have to understand what is your actually a principle to go for, despite whatever the case. So that's how you have to understand about the way you have to solve the actually linear inequality equations.